So you have done many courses and now you're going to apply that knowledge into projects. But you don't know how to do that. This video is for you. In today's video, we're going to apply our machine learning skills, the basic skills, the regression skills specifically, into Boston house data. So let's get into it. So welcome to the tutorial part of this project. So for now, what we will do is go to Kaggle, find the regression dataset which I already did, create a notebook, go inside Kaggle, find the regression dataset that I've already found for you, and just create a notebook inside Kaggle and use that dataset right there. Instead of just downloading it and just processing it, etc., that kind of stuff, we don't need that. The best way to set up your notebooks with dataset is Kaggle, by far. And yeah, I'm kind of biased towards Kaggle, but no website comes close when it comes to datasets and machine learning projects. Okay, so I hope you have guys found this intro like some kind of useful. Okay, so yeah, let's get into the project now. So for now, what I have done for you is found this where do I go? Okay, I think that is data paradox. So it is pretty basic regression dataset. It is not basic by the way, but yeah, I hope I would be able to give you much insights about this dataset and make you able to like work on future regression dataset quite good. Okay, so I will try my best. Let's get into it. Okay, so now one tip, if you just want to create a notebook inside Kaggle, just go to a dataset and the same new notebook that I've already done here. Let me just drag it. Okay, and let me just name this notebook as regression project S to E, start to end. Okay, or let's just say S to F, start to finish. Okay, so once we are inside a Kaggle notebook, you'll see an interface like this. Okay, there will be your data set here at the left hand side. As you can see, Kaggle working, and then there's a data set, it is an output. Also, you will have IPy notebook type interface, like a Jupyter notebook type interface, a Colab notebook type interface, whatever may you call it. Okay, so this is just your regular notebook. Okay, this is a regular Jupyter notebook or Colab notebook, anything else. Okay, so what you have to do is shift enter to get your notebook started. It will just connect to our runtime, and then what will happen is you can access all of the Kaggle's datasets through this notebook. Yeah, that's pretty much good. Okay, so the Boston house price data.boston.csv is already loaded, as I've already created on new notebooks from the dataset. So it has loaded that dataset already in my notebook. I hope you get my point. Okay, so now let's just get started. So for this project, we will use linear regression. So I'll give you a concept of linear regression, like then we will do loss calculation concept, and then measurement methods like roots, mean square error, and then other kind of stuff. Okay, and mean absolute error, obviously, that's the bare minimum, but let's just not do that for now. We will just do mean squared error and root mean squared error. Okay, and this will like give you a brief idea of what linear regression is, the model. Okay, so let's get started. So firstly, we'll import the necessary stuff that we require for this project. So now we will import matplotlib.pyplot as plt, and why is this here? Okay, Now we will import from scikit-learn dot model selection. Obviously, the most required thing. We'll import the train test split, and then we will import the cross-validation score. That makes sense. And then now from scikit-learn dot preprocessing, we will import the standard scaler. Import standard scaler in order to scale the values if anything is like out of bounds, and if there are any outliers or something like that. Okay, since we are using the mean squared error or mean absolute, it doesn't matter, but yeah, it might sound a bit of harsh if you like don't scale your values and just predict on that. That will just skyrocket those values. So yeah, we'll just keep an eye on that. And now let's now build pipelines for this project. Or not. We'll just import it for now. Okay, so scikit-learn dot pipeline. We'll import pipeline. Not pine line, but pipeline. Hope that makes sense. And then now from scikit-learn dot model selection, we will again import, this time grid search CV. What grid search CV does is it makes us easy to hyperparameter tune our model. So yeah, that's it. Now, in addition to that, we can just import more models, but for now, I will just stick to linear regression and I'll give an intuition along that. Also, there are many regression models like Ridge, then Lasso, then again many other models. Random forest regressor, there is also that one. Yeah. So for now, let's just import the linear regression. So from scikit-learn dot linear model, we will import linear regression. And by the way, I am the one who contributed to linear regression's recent issue on the scikit-learn's official Git repository. Want to check that out? Then you can. Okay, that's the imports done. Now what we will do is define our dataset. So let's say Boston equals to pd dot read CSV, and there is a string that I know already, so we will do Control C here and I'll just paste it. Okay, so the path is Kaggle input as defined here. From that, the Boston house price data and boston.csv. That's one thing to notice. Okay, that's it. So let's now get going with our EDA. So let's do info. As you can see, 5 or 6 entries. There are no null values. Okay, that's interesting. And there are no object values, so we are good to go. Yep. Quite good data and quite irregular data. Seems a little crazy, but okay, it's okay. We can work with it. So Boston.describe. And if we describe this, as you can see, the count are same, so there is no null value, and the means are quite evenly. No, they are not. The 408 got me there, 356 again, and yeah. I mean, the minimum values are also not scaled, so yeah, we do require min-max scale or like standard scale, doesn't matter. Okay, for now we'll just use standard scaler. Let's take a look at our data. So let's cut it ahead, and as you can see, there are so many columns like ZN, address, mouse, RN, age, which is not an integer. That's quite funny. I don't know if it's actual age or not, but I hope it is. But yeah, kinda good, kinda not. Doesn't matter. Okay, so let's get columns. So Boston dot columns equals to Boston dot columns dot str dot strip, and now we will just do Boston dot columns equals to Boston dot columns dot str dot lower. What this does is like to examine the relationship between the number of rooms and the house price. We just define number of rooms in a variable. So yeah, so let's just do that. Although let's just get columns here. It's columns. Yep. And what happened? Okay. Okay. Quite funny though. Don't have to worry. We'll just do x equal to Boston dot drop. We'll drop the columns and we'll do maybe x is equals dot values. Okay. I think it should find this. Don't you think? Yeah. Yep. It should find it. White. Disturbing. Okay. Let's do values. And let's just remove the axis for now. What? I don't know what's happening here, but yeah, I hope if I do columns equals to negative, okay, it again didn't find it. I guess we have to keep it in V, and yeah, that's the thing. Okay, I messed up. I have to do axis equals 1. Okay, so now what we will do is y equals to Boston of again V, and let's do values, and that should create our datasets, small datasets. So x rooms, as I said, we will just do rooms separately, and we will do x of let's say on 5, and do x rooms dot shape 506 and not. Yep, quite good. Okay, so now when we examine the dimensions of the rooms, we see that the size must be in a rate of n consisting of 5 or 6 rows, right, and 1 column. Let's do a reshape with a -1 1, so the column that is missing here will come there. You will know once I do that. Okay, so x rooms equals to x rooms dot reshape, and let's do -1 comma 1, and if I do x rooms dot shape again, x is capital, it should give us the missing column. And if I just check x rooms, Yep, that is in a single column, and that's how we want that. Let's do xrooms.shape for now, and that's it. Now let's just plot some rooms. Let's plot the number of rooms with the value of the house. So against the value of the rooms. So number of the rooms will be on the x-axis here, and the value of the house will be at the y-axis. Okay, hope that makes sense. So plt dot, let's do scatter plot x rooms, and let's do with y with plt dot x label as number of rooms. Okay, that I messed up. Also, let's just give it a title. plt dot title. What will be the title? Rooms versus let's say value. Okay, and let's do plt dot y label equals to, that will be value of the house, and that should be in the inverted commas, and that should do it. And let's just do plt dot show. And if you do this, okay, did I just, okay, I messed up here. Okay, so as you can see, the plot says as the number of room goes up, the value of the house goes up. Although there are many houses with a value of 10 to 25, I guess, if consisting of 5 to 7 rooms. Yeah, that should be a good number of rooms there, although there are some outliers here and there. Yeah, let's check that out. Okay, so let's just apply what we call a least square method using linear regression onto this data. So we'll just show it also. Okay, so let's just do reg model equals to linear regression, and now what we'll do, reg dot fit, we will fit the x room, not c rooms, obviously the x rooms with the y. Okay, and we will do prediction spaces, head space equals to np dot linspace, I hope that is, yep, linspace with minimum of x rooms. Okay, and maximum of x rooms. Then what we'll do is dot reshape it to -1, just because of that single column missing, and that should do it. Yeah, so now let's just show it. So plt dot, let's do a scatter plot with x rooms and y with a color, let's say red, and yeah, that looks fine. And let's just do plt dot plot. Here's how it goes. So preds space, then reg dot predict, we'll do red space, then we will do a color of black to the line, and then what we will add, a line width of, let's say 2. I hope that's not much thin, but yeah, plt dot show if I do this. Yep, as you can see, there are points, and that's how our linear regression model is going to fit on this data. Now, what is a least squares method? There's a video available on the channel that will be linked in the description. Okay, that is given by Prashasti, I guess, one of my colleagues. So yeah, she has explained this in a very good way, so I'll just link it down to it. Okay, so now we have done the least squares method using linear regression, and that's how that has fit to this dataset. As you can see, not so good, right? Obviously, it's a linear model. That's why that is a straight line, and also the slope is kind of wacky. But it's a good start for this dataset. Although, let's just split the data into training and testing set. So what we will do is xtrain, then do xtest, ytrain, and ytest. We will do train, test, split. We will pass it the capital X, comma Y, and let's just do test size of 0.2, and let's just do random state of obviously 42. That is a double equal to, I'm sorry. Okay, I hope you have got it. This will now split our data into a 80-20 format. So 80% of our original data will be given as the training data to the model, and the 20% will be kept as a testing data. Okay, so that's it. So let's do regression of all the things we have. So let's do reg all is linear regression. So reg underscore all dot fit. What we will fit? The xtrain, then the ytrain. Okay, and now let's run this. So yeah, the linear regression has been fit. Now let's predict. So regs equals to reg all dot predict. Let's call the predict function, and what we will predict? X test dataset. Okay, what happened here? And underscore. Yep. So if we just visualize spreads, wow. Yep, that's it. And if we reshape it, spreads dot reshape, although we don't need that, with the -1, 1, we should see it in a column format. Yep, that should do it. We don't need this, we already need normal spreads, so we already have those. Okay, so now let's calculate the matrix, the root mean squared error. So if we do the RMSE equals to np dot sqrt, and if we do mean squared error, did I just import it or not? Because it is not showing there. I obviously didn't import. Yep. Okay, so from scikit-learn dot matrix import, what are we importing? Mean squared. Okay, that's it. And now if I go here at this cell and again type this, it should show me the mean squared error. What it will take? The y test the actual values first and then the pairs. We ran that, and let's just now print it. So if I do print, do root mean squared error, and do, let's use the formatted strings. If I do if here, and let me see, close this. If I run, okay, nothing happened. I don't know why. If I run this again, nope. Oh, that's why. Format. Okay, I'll try something more. Dot format. I hope formatted string work this way in Kaggle. I don't know. I'm just using the Kaggle notebooks on the second time. But yeah, that's a problem. Did I do anything wrong? I don't think so. Yeah, the F doesn't make sense when you use format. But yeah, nope. Let's just do normally. You know what? Let's cancel this. And let's do RMSE. Okay. Okay. If we run this again. Nope. 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 No output. I don't know why. Okay. If we do print RMSE, print that, no, but if we do here, it is not going to get printed. I don't know why. If I do code down here and say print, say hello, yeah, that is not working for some reason. You know what, let's just stick to this cell and let's say RMSE. Finally. Yep. Pretty good. Okay, I hope this doesn't do anything wrong, but I don't know why these cells are not working. Although I have to create a cell by my own hand every time now. Okay, that's a problem. So let's just do cross validation. Let's just do CV score is equal to cross val score, and we will do reg all and pass it x, then y, then CV equals to 5. And so this will do folds in a 5 folds of cross validation. Also, if you want to check that out, what cross validation is actually, it already, I'll tell you in a short description. It actually takes your data and splits it into 5 halves by random and tests on those 5 halves. So every time the model takes in different parameters, like different examples, and tests, it is being tested on the different parameters. So I hope you get the point. If you want to dig this topic down, there's a video linked in the description again for cross validation, again by Prashasti, my colleague. Okay, so let's just take that out. Okay, so if I do print CV scores, yep, every time there is a different accuracy score. As you can see, for some data it is 0.07, although for some data is minus 1.25, 0.25. Yeah, and for some data it is even 0.63. So that's the beauty of working on multiple process, like multiple folds of a data. Okay, so let's just average the 5 of those folds. So let's do print average of CV cross validation, and what we will do is np dot mean, and we will pass it the CV scores. Yeah, that is an overall 0. The overall 35% of accuracy through the cross validation. So I hope you get my point. So now let's use the rich function. You know what? Let's use the rich function actually. Let's import the rich function, and for that we just need to import from scikit-learn dot linear model import rich. Yep, that. Come down here, make a new code cell, and now what we'll do is make a rich function, like do a rich function for our regression dataset. It actually uses L2 regularization techniques in order to do regression, so it is more efficient. You can just take that in mind for now. Okay, so let's do rich equals to rich, we will do alpha of 0.1, or let's say 0.01, makes more sense. Okay, so rich dot fit, what we will fit again, the xtrain and then ytrain, then we will do rich dot threads underscore threads, I mean, so rich dot predict, and we will predict the next test. That should do it. So let's just do it in one cell, because these cells are getting in a way. So RMSE, that is root mean squared error, will be equal to the np.sqrt of mean squared error, where we pass the y test as the original data and rich threads as the prediction. Okay, and that should do it, and let's just print the RMSE. Yep, 4.92, and here 0.35. Oh, my bad. Actually, here it was not a percentage, but it was a mean squared error. My bad, I put it as a classification report, but yeah, my bad. Okay, so here the values are differed by point, although here it is differed by 4 point. So in our case, normal linear regression is far more better than the, what do you say, the rich function. Okay, so yeah, although now you can use some lasso and other kind of stuff, and you can make pipelines to like predict the data using those models and etc. Whatever you want to do, whatever you like, you can do it. This is machine learning, and you have all the control over you, over your models, over your datasets, etc. Okay, and that's it. That's how you apply all the knowledge that you have gained throughout the tutorials into an actual project. Although this is not an end-to-end project, you want to deploy this project, these kind of projects, I have done the tutorial in the customer service chatbot tutorial, and you can check that out in the channel. So this is Atharva from Pi Analytics. For now, bye-bye.